Hi guys, this is Miss Igo. Welcome to my classroom. In this video, we're going to be talking about the multiplication principle. Suppose n choices must be made with m sub 1 ways to make choice 1 and m sub 2 ways to make choice 2, all the way up to m sub n ways to make choice n. Then there are m sub 1 times m sub 2 all the way up to m sub n, different ways to make the entire sequence of choices. So let's apply this principle. An auto manufacturer produces 6 models, each available in 8 different colors with 4 different upholstery fabrics and 3 interior colors. How many varieties of the auto are available? Well, according to the multiplication principle, we can take each choice, the 6 models, so we have 6, and multiply that times, there are 8 different colors, so we're going to multiply that times 8. There are 4 different upholstery fabrics, so we're going to multiply times 4. And there's 3 interior colors, so we'll multiply times 3. So we just multiply 6 times 8 times 4 times 3, and we get 576. So there's 576 varieties of the auto available. A password used to gain access to a computer account is to consist of 2 lowercase letters followed by 4 digits. Determine how many passwords are possible if repetition of letters and digits is permitted. First of all, let's determine how many characters are going to be in the password. So if it says 2 lowercase letters, okay, there's going to be 2 lowercase letters followed by 4 digits. 1, 2, 3, 4. Okay, so for this first example, it says repetition of letters and digits is permitted. So for the first, these 2 are letters. For the first letter, there are 26 letters in the alphabet, so that means for this first letter, there's 26 possibilities. For the second letter, because repetition is permitted, it doesn't matter what letter we used in the first position, we still have a choice of 26 letters to go in the second position. And then the next position is to be a digit. The digits is a single digit, so we could either have 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, which, because we're counting 0, gives us 10 possible choices for a digit. Again, there are 4 digits, and we're told that repetition is permitted, so those same possible 10 digits that could go in this position could go in the rest of the positions. And based on the multiplication principle, all we need to do is multiply those together. And when we do, we get 6,760,000. For example number 2, we still are going to have the same number of positions. So we're going to have 2 letters followed by 4 digits or 4 numbers. But this time it says repetition of letters and digits is not permitted. So in the first position, when we have a letter, that very first one, we can choose from any of the 26 letters in the alphabet. But because repetition is not permitted, in our second position, whatever letter was used in the first position, we can't use it in the second position because repetition is not allowed. So that means we only have 25 choices left in the second position. The next position is a number. So that first number position, we have 10 choices of numbers to go in that position. In the second position of the digits, we now only have 9 numbers left to choose from. In the third one, we've already used one number here, so now there's only 8 numbers left to choose from. And then in the last position, well, we would only have 7 left to choose from. So again, we would just multiply all of those numbers together, and that would give us 3,276,000 possible passwords. In the last example, it says the first letter must be a vowel and the first digit cannot be a 0, and repetition of letters and digits is not permitted. Okay, so we're still going to have the same number of characters, so 2 letters and 4 digits. But the first letter must be a vowel, A, E, I, O, or U. So that only gives us 5 choices of what can be in the first position. Repetition is not allowed, so whatever we used in the first position cannot be used in the second position, which limits our letters to 25. Then the first digit cannot be a 0. Therefore, instead of 10 possible choices for our digits, we only have 9 in this first position. In the second position, we can use a 0. However, whatever number we used in this position, we can't use in this position because we can't repeat. So we still only have 9 possible choices for that second digit. And then again, repetition is not allowed for the rest of the positions, so there would be 8 choices here and 7 choices here. And then we multiply all those together, and that gives us 567,000 possible passwords. At the reception line of a wedding, the bride, groom, best man, maid of honor, 4 ushers, and 4 bridesmaids line up to receive the guests. If the individuals can line up in any order, how many arrangements are possible? First of all, we need to determine how many people there are in the wedding party. We have a bride, a groom, a best man, a maid of honor, 4 ushers, and 4 bridesmaids. So that's 1, 2, 3, 4. 4 more is 8, and 4 more is 12. So there's 12 people in the wedding party. Now, if the individuals can line up in any order, how many arrangements are possible? Okay, so we would start with, there's 12 possible people that could be in the first position. Then the next position, there's 11 because the same person can't be in 2 places at once. So 12, then 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. And that used every person, because there needed to be 12 positions, there were 12 people. And then to find out how many arrangements are possible, we're going to multiply all of those together. So if we multiplied 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, we would get 479,001,600 different ways to arrange those 12 people. If the groom must be last in line and the bride must be next to the groom, and the others can line up in any order, how many arrangements are possible? So let's go ahead and just put blanks for the positions. We know there has to be 12 positions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it says the groom must be last, so there's only one person that can be in that last position. And the bride must be next to the groom, so there's only one person that can be in that position. There were 12 total people in the wedding party. So that means if we have a particular person in this position, a particular person in this position, that leaves only 10 that could be in the other positions. So in this first position here, there's 10 possible choices that could be there. And of course, again, we're talking about people, they can't be in two places at once, so there's only 9 left that could be in this position, and we'll go down from there. 8, 7, 6, 5, 4, 3, 2, and 1. And then we will multiply all of those together and see how many possible arrangements there are. And when we multiply them together, we get 3,628,800 possible arrangements. If the groom must be last in line and the bride must be next to the groom, and the males and females are to alternate, how many arrangements are possible? Okay, so once again, let's put blanks for the total number of positions. And there's 12, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we'll start out with the groom has to be last. The bride must be next to the groom. And then the males and females are going to alternate. Well, if you'll remember, there was a best man, that's one male, and then the 4 ushers are male, so that's 5 total males. And then there's a maid of honor, which would be a female, and 4 bridesmaids, which makes 5 females. So there's 5 males and 5 females. And if we're going to alternate, in the first position, if we start with males, there are 5 possible males that could be in that first position. We want to alternate, so then there's 5 possible females that could be in the second position. Now that we've used 1 male in the first position, there's only 4 males left that could be in the third position. And the same with the females. There's only 4 left that could be in the fourth position. And we're going to alternate 3 possible males, 3 possible females, 2 males, 2 females, and there's only 1 male left and 1 female. And again, we multiply all of those together, and that gives us 14,400 possible arrangements. How many different hitting lineups can be formed for a 9-person baseball team? If we want to use all 9 people on the team for the lineup, let's put our 9 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9. In the first position, there are 9 different players to choose from. In the second position, you can't bat in more than one position. So in the second position, there's only 8 choices left. And then the third position, there's 7 choices, followed by 6, 5, 4, 3, 2, and 1. And again, to determine how many different lineups can be formed from this, we're going to multiply all of these numbers together. And when we do, we get that there are 362,880 possible lineups from a 9-person baseball team. The use of the multiplication principle often leads to multiplying consecutive natural numbers, such as 5 times 4 times 3 times 2 times 1. We saw in our last example where we had the 9-person baseball team, we started with 9 and went down from 9 to 1. So if n is a natural number, then the symbol, this right here, n, and it looks like a little exclamation mark, which is read n factorial, denotes the product of all the natural numbers from n, whatever that number you start with, down to 1. So if we write 5 factorial, that means the same thing as 5 times 4 times 3 times 2 times 1. And if we were to multiply all of those together, we get 120. So the definition says for any natural number n factorial would be that number times 1 less than that number times 2 less than that number, and so on until we get down to the number 1. We multiply all of those together, and that's what n factorial would be. Also, the definition tells us that 1 factorial equals 1 and 0 factorial equals 1. Let's evaluate each expression. In the first example, we have 4 factorial. Well, we just learned that 4 factorial equals 4 times 3 times 2 times 1. Well, we can put that in our calculator, 4 times 3 times 2 times 1, or we can put 4 factorial in our calculator. And I will link my video on how to put factorial in your calculator down below in the description. So if you do 4 factorial in your calculator, you will get 24. To get 9 factorial divided by 6 factorial, you can either write it all out. So that would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. And you know, when we're dividing, we can divide out. Sometimes you say cancel out the numbers that are the same in the numerator and the denominator. So that would just leave us with 9 times 8 times 7. Or in your calculator, you could put 9 factorial divided by 6 factorial. And either way, you would get the same answer, which would be 504. And then in the last example, we have 5 factorial divided by 2 factorial times 3 factorial. If we were to write this out, 5 factorial is 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1 times 3 factorial, which is 3 times 2 times 1. And again, if we divide out what we have in common, and then 2 can divide into 4 2 times, that's just 5 times 2 divided by 1, which would be 10. Again, you could just put 5 factorial divided by 2 factorial times 3 factorial in your calculator, and you would get the same answer. I hope this video helped you. If it did, make sure to share it with a classmate and be sure to subscribe to my channel. Thank you so much for watching.